Hello! Now I'm going to explain how to solve radical equations. First, take few seconds to read the how to solve. The step-by-step process. The first step is related as solving the equation for the radical that contains the variable. Second step means to rid of the radicand, raise each side of the equation to a power equals to the index of the radical. The third part is combine the like terms. In the fourth is check if we have more than one radicand and repeat the steps. Solve the equation for the radicand, raise both sides of the equations, and 5, solve the resulting equation and check all solutions in the original equation. 4, extraneous solutions. Extraneous solutions means false solutions, that solutions that even that you get it in the process are not according to the original equation. Let's work with example number 1 to find the radical equation. Example number 1. 2 cubic root of x minus 1 equals the cubic root of x squared plus 2x. So, as we can see, step number 1 is done. The equation is rewritten in terms of one radical, or the cubic root equals some expression. Now we have to apply the second step. We're going to raise the equation to the index of the radicand, 3. Raise it to the third power. Raise it to the third power. Is raised. So, as I told you, it means that we're going to rid of the cubic root. For this side of the expression, cubic root is gone. Cubic root is gone. So we have x squared plus 2x. And on the other side, we'll have to apply properties of exponents. We have the cubic root, a multiplication of two terms, so 2 to the third power, 2 to the third power, times cubic root of x minus 1 to the third power. So we can apply the same property we applied on the left side, on the right side, to say that is 2 to the third power factor of x plus 1. Next step, we have to combine like terms. Combine like terms. 2 to the third power is 8. 8. And if I apply distributive property, 8 times x, 8x, 8 times 1, 8. So is 8x minus 8. Let me correct the negative sign. 8x minus x equals x squared plus 2x. We have to continue combining like terms. I'm going to subtract by 8x. Subtracting by 8x and add 8. Add 8. and simplify. 2x minus 8x is minus 6x. Now we can go to the next step. Solve the resulting equation for the variable. How to solve it? By factoring. So we just have to factor the equation by using the trinomial x squared plus bx plus c. b minus 6, c is 8. We have to find two numbers whose product is c, 8, and whose addition is minus 6. These numbers are minus 4 and minus 2. And finally, apply zero factor property. So if I apply zero factor property, I have x minus 4 equals 0, so the first solution is x equals 4. And the second solution, x minus 2 equals 0, so x equals 2. We have the solutions. Now we have to check solutions. Last step. Check solutions. First solution. First solution is x equals 4. X equals 4. So we're going to use x equals 4 in the original equation. X equals 4. X equals 4. 2 times 4. 2 times 4. 2 times 4. Let's simplify. 4 minus 1, 3. 2 cubic root of 3. 4 squared, 16. 2 times 4 is 8. 16 plus 8, 24. Is the cubic root of 24 equals 2 cubic root of 3? Simplify the cubic root of 24. So check. Cubic root of 24 is the same as the cubic root of 8 times 3. But 8 is 2 to the third power times 3. This is the prime factorization. And if I apply properties of exponents, this is cubic root and this is a cubic, so 2 could be out of the root, and what is left is the cubic root of 3. Cubic root of 3. Yes, it's the same. So we check the first solution. Second solution. Second solution is the same equation, but now x is 2. X is 2. 2, 2, and 2. Second solution. 2 minus 1, 1. 2 to the second power, this is 4 plus 4, 8. And as you could see, the cubic root of 1, so is cubic root of 1 is 1. We have 2 equals cubic root of 8. That's true. That's correct. Cubic root of 8 is 2. So both solutions are allowed. we just write the answers again. And we have finished the first exercise. The solution of 2 times cubic root of x minus 1 equals cubic root of x squared plus 2x is x equals 4 and x equals 2. Let's see the example number 2. This is example number 2. 3 plus square root of x plus 1 equals square root of 3x plus 12. Step number 1 is done. This side of the equation is solve for the radicand. Now we have to apply step number 2, raise to the second power the index of the root. And if you can see here, we have a perfect square trinomial. 3 will be a, square root of x minus 1, x plus 1 is b. So apply the perfect square trinomial to the left side, the expression of the left side. A, 3 to the second power 9, plus 2 times a, 6, times b, square root of x plus 1, plus square root of x plus 1 to the second power equals, we rid of the root, 3x plus 12. So we have to continue simplifying to combine like terms. How could you simplify? All this square becomes x plus 1. We rid of the root with the square. And combine like terms. How do I combine like terms? This x, it's moving to subtract 3x minus x, 2x. 9 plus 1 is 10. Now I can pass it to subtract. I have 12 minus 10. This is 2. And look at that, we have a variable in a radicand, so we have to repeat the steps 1 through 3. Again, rewrite the equation, rise each side, and combine like terms. So to solve this expression, I just have to divide by 6 each member of the other row, or divide everything by 6. Some people prefer to raise to the second power now and write 6 as 36, but I'm going to follow the steps that I established already. It means that you can do it? Yes, you can do it. In fact, if you can notice, we can have a common factor, 2. So we can rewrite the expression of the numerator as 2, a common factor of x plus 1. And we can simplify this 2 with 6 to have 1, and instead of 6, 3. Okay? Let's raise again to the second power. Raised to the second power. Why to the second power? Because we have a square root. A square root. So let's raise it to the second power. Raise it to the second power. Remember that if I raise to the second power a denominator, I can apply properties of exponents. properties of exponents. Now, if I raise to the second power, this term becomes x plus 1. We read of the fraction, x plus 1. This term is a perfect square trinomial. Perfect square trinomial. X squared plus 2 times ax times b, 1, 2, plus 1. Divided 3 to the second power, 9. Now we're going to simplify and combine like terms. Some people don't like fractions, so I'm going to pass 9 to multiply. Multiply by 9. Multiply by 9. 9x plus 9. Remember to multiply each member. Equal to the trinomial, the numerator. I pass to multiply by 9, or it's better to say multiply each side of the equation by 9. Apply distributive property, 9x plus 9 equals the trinomial. Combine like terms. Combine like terms. So 9x, I can subtract by 9x, 2x minus 9x, minus 7. And I can subtract to each side by 9, minus 9. We have here minus 8 and 0. Solve the equation. Look at another trinomial. Another trinomial. How to solve the trinomial? X squared plus b plus c. B is minus 7, c is minus 8. Two numbers whose product is minus 8 and whose addition is minus 7. X minus 8 and the other member x plus 1. Minus 8 times 1 minus 8, minus 8 plus 1 minus 7. And apply zero factor property. Apply zero factor property. So if I apply the zero factor property, I have my two solutions. X equals 8, x minus 8 equals 0, and x equals 1. Both are solutions of the equation. Check. First, so we're going to check the first solution, 8, in the original equation. 3 plus, so instead of x, 8, here, times 8. Times 8. 8 plus 1, 9. 8 times 3, 24. Square root of 9. Square root of 9. The square root of 9 is 3. 24 plus 12. This is 36. 3 plus 3 is 6. And 6 is equal to the square root of 36. So first solution is a law. It's not extraneous. Second. So second solution is with 1. With 1. Instead of 8 is 1. Instead of 8 is 1. Excuse me, it's not 1, minus 1. X plus 1, zero factor property, solution is x minus 1. So minus 1 and minus 1. So 3 plus, this is 0. And the square root of 0, so 0. And this is 3 times minus 1 minus 3. 12 minus 3. 12 minus 3 is 9. Is 3 the square root of 9? Yes. So second solution is not extraneous. Answers: x equals 8 and x equal 1. X equals minus 1, minus 1, minus 1. So this is the way you solve radical equations. You can try example number 3 to see if you understand. It's with functions. Given the functions fx equals a cubic root of 5x minus 19 and gx equals cubic root of 6x minus 23, find the points of intersection. So basically what you have to do, points of intersection are when fx equals to gx equals to g as a function of x, and you have to solve the polynomial, the radical equation, cubic root of 5x minus 19 cubic root of x minus 19 equal to the cubic root of 6x minus 23. So you have the radical expression. We just have to solve the equation and find the solution. If you like to try it first, pause this video and try it. Now you can watch the solution. The solution is applying the radical equations, how to do it, the algorithm, how to solve the radical equations, and I'm going to follow the steps. The first step is done. Now I'm going to move to the second step. I'm going to raise to the third power to each side of the expression. Raise to the third power to each side of the expression. Each side of the expression. I raise to the third power each side of the expression. In this way, I rid of the root. So we have 5x minus 19 equal to 6x minus 23. Combine like terms. 6x minus 5x is 1. So 1x, x. And I can move 23, positive 23 here. 23 minus 19. 23 minus 19 is 2. 23 minus 19 is 4. X equals 4. And if x equals 4, if x equals 4, then we have for fx 5 times 4, 5 times 4, 5 times 4 is 20. 20 minus 19 is 1. And cubic root of 1 is 1. So we have just one point of intercept, just one solution, so just one point of intercept. Look that the solution is not extraneous. If you check on gx, 6 times 4, 24 minus 23, 1 as well. So the point of intersection is x equals 4, y equals 1. This is the point of intersection. And this is how to solve radical equations. Remember the steps and remember when we want to find the points of intersection between functions. Thanks for watching.